All right. Well, greetings, Owyhee enthusiasts, many of you, and stargazing enthusiasts, many of you, and also both of those, many of you. Thanks for joining tonight for our, must be the third stargazing presentation of 2022. So this is the Friends of the Owyhee webinar series. Once a month, about in the middle of the month, we host a webinar with some expert content. And every other month, we've been hosting a stargazing lesson, kind of an introductory stargazing lesson. And as we did during 2021, all 12 months. But this year, we decided to stagger every other month with another expert content guest lecture. So we've had a presentation on Owyhee bighorn sheep, which was fantastic, from the Oregon Department of Fish and Wildlife, to learn about the decimation of the poor bighorn sheep herds out here in the Owyhee. And then last month we had Susan Fritz from the Bureau of Land Management join us to talk about a really great project that she has on collection of wildflower seeds here in the region, and then also growing those out so those native seeds can be disseminated, particularly after wildfire, so we can be reseeding areas that have been burned with native plants. Okay. Thank you again for joining us. My name is Sammy Castonguay. I have a master's degree in geoscience and had the good fortune at some point to be inspired by the night sky while camping with many young geologists. I also teach at Treasure Valley Community College in earth sciences. So that includes geology and astronomy, meteorology sometimes. And my winter class in astronomy, we spend about half of the 10-week course really focused on this eyes on the sky perspective of astronomy, which I think is a lesser part of many other astronomy courses that tend to focus a little bit more cerebrally on the starship perspective, is what I call it in my class, which is let's take a satellite or a starship to another planet or to another solar system or to another galaxy and learn about the cosmos. So I tend to minimize that in my class in replacement for this, this almost rudimentary technique of stargazing. I feel like it's somewhat of a lost art, and it's my pleasure to share it with all the students that come into my class. And then when us here at Friends of the Owyhee decided to launch a webinar stargazing resource, it's also been a thrill to talk to all of you and then to hear from you in between stargazing lectures about what you've been seeing. So don't hesitate to email me or Catalin, or just use the contact at the website to engage about stargazing if you ever happen to see something you have a question about. Okay. Now, before I move on, I'd also like to recognize where I'm sitting right here, where I'm joining you from, as well as the Owyhee volcanic plateau, the Owyhee watershed to the south of me, which is what the Friends of the Owyhee Conservation Advocacy Group sees ourselves as stewarding, that this is all the ancestral territory of the indigenous Native Americans that were forcibly removed from their home during the 1800s. So an acknowledgement of these atrocities is sort of the least that we can do, absolutely, but also keeping this knowledge with us as we explore this territory, either on foot or by wheel, and also in this case, as we go out and stargaze and think about the natural wonders and beauty around us, and of course, the people of the land. So this was mostly Northern Paiute tribes and bands. To the east, Shoshone Bannock, and then also some Western Shoshone influence. This map that I'm showing you is from the website nativeland.ca. And you can visit that website. It's a global map that you can zoom in and zoom out to find where you live, to see whose territory, ancestral territory, you are occupying today. And I highly recommend you go do that and become aware. If you're not already, I imagine many of you are, of the indigenous Americans that lived here and still do live here all around us, and some on reservations. Okay, so let's move on to stargazing. This is my basic 3-point overview of what we're going to hit tonight. Number 1, gear, awareness, and process. I'll sort of minimize that because a lot of this discussion is archived on our YouTube page and other lectures. So you can review some of that stuff there. And then I want to really emphasize tonight the importance of natural night skies and some of the projects that Friends of the Owyhee are engaged in. And then tonight's subject matter, which is really exciting. I've been watching this for the last month, and possibly some of you have also been seeing these mysterious objects in the sky over the last month. And then for the next month, we'll be able to see many of these objects as well. So what we're going to talk about tonight are the visible planets, okay, those that we can see with the unaided eye out there. Okay, so here's a couple of slides taken from lectures last year. Again, they're archived on our Friends of the Owyhee YouTube page, but I would be amiss if I didn't just mention that as you stargaze, please dress properly. I highly recommend a red headlamp or a red light if you're going to be out for a little while and maybe taking notes or looking at a constellation guide or some resources, because the red wavelength of light is less harsh on your rods and cones, so you can maintain your night vision. Okay, once we get that blue wavelength in there, the really bright lights, that tends to diminish our ability for our eyes to pick up on the small lights in the sky, the stars. So red headlamp, warm clothes. It does get cold at night, even here in the spring and the summer, and in the morning, which we're going to do morning stargazing during this lesson. So dressing appropriately, because that really diminishes your experience if you go out and you're cold and you're miserable, or particularly if you take children out and you want to have a good time out stargazing with your nieces and nephews or grandchildren. Make sure that they are also well prepared. I like to take a drink, hot cocoa, something warm. Is always nice. Some tea warms up the inside of the body. So that's a little bit about some of the gear. There's plenty of also resources available, like constellation guides. There's wonderful books out there available. I recommend A Walk Through the Heavens is one that I use to learn a lot of the constellations. And then if you're into, using your space phone, which, who isn't, there's an app for everything. I would highly recommend the app Stellarium. It does cost a couple of dollars, but it has lots of wonderful bells and whistles, including a red vision, so you don't blind yourself when you open it up. There's some other star apps that are available, but I really like Stellarium. It's what I recommend in my class. They also have a desktop app if you want to do this stuff at home on the desktop that's a little more powerful. Okay, and and then let's also acknowledge that to be sort of successful in stargazing, or success is an odd measurement, but to feel as if you have begun to internalize the night sky. So that means that you can walk out on your own, cold turkey, and start to look around and identify things. And that's all in setting your awareness and your process. Getting an idea of when the cardinal directions, when the sun rises or the sun sets, the moon phase. I also like to make the sky kind of a hands-on feature as well. So you can extend your hand at arm's length away, and that angular distance with your fingers, about 10 degrees, 18 degrees, 1.5 degrees, and so on. That allows us to measure the distance between stars, the angular distance between stars, so we can communicate it to each other. Okay. And then a last part of this, the setting awareness, and the last part of this process is practice, right? Learn one thing at a time. Go look in one specific area and apply what you've learned, maybe from this webinar or from a book. Apply that, learn it really well, remind yourself of it, practice it a couple of times before you move on to a new area of the night sky. Okay, learning one thing at a time can really help, just like math. All right, I'd like to address these 3 topics when we're talking about the importance of natural night skies. So number 1, that the natural night sky is a cultural resource for all of us, all humans and animals, I suppose, alike around the world. Then B, light pollution and solutions. If we're talking about natural night skies, then what is the other side of that? What's the antithesis? And that would be, of course, light pollution and the sky glow. So I'll talk a little bit about the Oregon Outback Dark Sky Initiative, Sanctuary. Sanctuary is the official word, but it is quite the initiative by a network of folks out here in Eastern Oregon. And then lastly, I'd like to talk about how you can be involved, whether you live in the Owyhee region, in Malheur County, in Eastern Oregon, in Idaho, or in South Dakota. The understanding, gaining a global understanding of the darkness of the night sky through various locations of Earth is very important right now. So we catalog exactly how dark it is and begin to preserve these areas for their pristine darkness. Okay, so that can be done anywhere all over the globe, and I'll give you a few things to work with there. So my last comment there, if you like the stars, which you're here to learn a little bit about Introduction to Stargazing, so you've probably already admired the night sky. I'm guessing you are already an advocate. You just might not know it, but please be an advocate for dark night sky. Just a simple comment to a colleague tomorrow or next week about the night sky. Oh, I saw a neat constellation. Oh, did you see those planets over there? The lunar eclipse the other day, right? When these things happen, we are able to bring them up in our workplace or in our general community, and then they sort of go away. But if we have that conversation that's about the beauty of the night sky, the next part of that conversation is, how do we protect this resource? How do we conserve this for future generations? So for instance, being here in Ontario, Oregon, it's not really that large of a town or a city, but it's really grown in the last couple of decades, as cities do, as population does grow. And what comes along with that, of course, are lights here and lights there and lights there. So it has been getting significantly brighter in this town. I feel like even since I've become aware of this, I've lived here for about 7 years. So if you like the stars, please become an advocate for the dark sky, at least by just talking about it with friends, family, and colleagues, and then taking that next step to maybe write a letter of support to get involved in the International Dark Sky Association, or to talk to us at Friends of the Owyhee about what you can do to help the Oregon Outback Dark Sky Network here in Malheur County. So as I mentioned, this is a cultural resource, folks, right? It really, in my mind, it doesn't get more multicultural than the night sky. You can look around all over the planet in all indigenous cultures, right? And all colonial cultures for that matter. And somebody has something to say about the stars. We as in humans, we have been looking at the night sky for thousands, tens of thousands, and possibly hundreds of thousands of years as a species, and taking in not just the beauty of the night sky as a given part of our life, but also, of course, taking that inward as some sort of inward reflection. And so the cosmos, the heavens maybe. And to many people, in the sort of the gradient between spirituality and religion, have taken the night sky very seriously for thousands of years. And this is a beautiful and rich resource that unfortunately we don't spend very much time on these days. We have devices that keep us busy. They're nice and lit up inside. We have all this artificial lighting. We have a nice climate controlled house. And it gets more and more difficult, as many of you know, for us to interact with nature, period. But then also the night sky, as we withdraw inward into the house and use our lights, we seem to see less and less of the night sky. But it's astonishing, right? I'm sure that you've been with a young child where they see the moon from the car and they're like, oh, the moon is out. And it's like, oh yeah, okay, kid, the moon is out. I mean, not really. I'm sure you're not like that, right? But it does catch me unaware sometimes that that childhood perspective of the night sky is a little bit more raw. And somewhere through, growing older, like so many things, we lose a little bit of that. Okay. But I would argue that this is the reason for protecting natural night skies is really a multicultural endeavor globally. And I'm very proud of us here at Friends of the Owyhee and those involved in the network that we're taking this very seriously here in Malheur County and across the Oregon Sanctuary and hopefully Idaho and Nevada as well, that we really want these skies to remain dark for generations to come, because we know that areas like cities are just going to get brighter and brighter and brighter. Okay, so I have a couple of neat images here. You've probably looked through all of these already, but this cave image is from 14,000 years ago in Central Africa. And scholars suggest that the tapestry that this shaman is wearing, the bee face shaman, is actually a tapestry of the night sky, thinking that there was a religious or a spiritual connection between the acts of the shaman and the night sky. And then there's things like Stonehenge, the Great Pyramids of Giza, Teotihuacan, the Christmas story around the stars. Of course, all of the familiar constellations from Greco-Roman culture. There's Orion down in the lower right-hand corner. And then also, let's not forget and undersell that all indigenous cultures, many indigenous cultures, have legends and myths and their own shapes and constellations of the night sky. So here's a wonderful book from South Dakota Territory on Lakota star knowledge. Wonderful resource that talks about the sacred hoop, which is something I've introduced here as the winter circle. Okay, so let's talk about then, if the night sky is such a wonderful cultural resource, okay, maybe we can agree on that, but then is it threatened? What is the threat? And absolutely, it's threatened by the emergence of light pollution. But to every problem, there's always a type of solution. So here's the problem. A few years ago, this resource was produced, a New World Atlas of Artificial Sky Brightness. And this was produced using high-resolution satellite data and precision sky brightness measurements. So some of this was ground truthed, those are the sky measurements, and then also some of this is satellite data and some algorithms produced on the light that's emitting from a town. So the point there is there's more that we can do to fill in the gaps of knowledge about light pollution and where it extends and where it doesn't. So here's what we know right now from this previous report. So the darker colors coordinate to a darker night sky, and then as you get to the cool colors, into the warm colors, and finally to the bright white, this is bright, right? So the units here are the candela, the standard unit of luminous intensity or brightness of light in a specific direction. Okay, so intensity is one of the kind of main words I would say there. And then if you look at the numbers that are over here, the really dark color, okay, which is only present in a few places. So let's look at the gray, the dark gray and the gray. But these units are in microcandela per meters cubed. So meters cubed is a surface area, and how many candela or intensity of light are spread over that meters cubed. Okay, and you can see there's a huge difference between some of these really low numbers down here. By the time you get to dark blue, 6 times as much light as the dark gray. And then all the way up to the really white, which you're over the 7,000s of units here. Okay, so this just sort of paints the picture then, right? Look at the eastern seaboard all the way into the Midwest. You have bright, 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 bright lights. There's almost nowhere in between where you can get to see this really dark gray, gray, or even the dark blue colors. But you come out here west of the Mississippi, cross the Rocky Mountains, and you got all kinds of open prairie space out here where there's little to no infrastructure. So there's not very many lights, and those lights that do exist are small towns and barn lights on ranch houses. So this is the information we have now. And with this information, some of the solutions then, first of all, as we continue to implement lights around the planet, the least we can do is use lighting that makes sense, right? So what does that mean? That means, sorry, I cut this off a little bit here, but that means using a type of shielded or focused light. So this is just one of these mini images. You can probably Google it right now for, you could say, sensible dark sky lighting or something. But the idea here is if you have a street lamp or if you have, a floodlight, ideally, we're projecting light into an area because we want to work there. Perhaps maybe it's construction. Maybe we want the area illuminated for safety. Maybe we want a light on to indicate that there's somebody home, these kind of things. Now, there's a lot of reasons that we want well illuminated spaces. But as we're illuminating, there's no sense in illuminating up, right? Nobody lives up there. Nobody's doing crime up there, right? Nobody's traveling up there. We don't have jets and cars. So keeping the light shielded, preventing it from casting a bright light up into space, which because the molecules in the air curve the light, if you cast light up from a city, then it's bent in the atmosphere and it comes down. I mean, it's what do you call that? It's reduced with the square of the distance over time, but eventually that casts a large bubble that you can see for hundreds of miles away. That feeling when you're driving through the night and you can see the next city as you approach. That's the kind of effect that we have here. So first of all, let's use lighting that makes sense. And then second, what we are in the process of doing now, as well as many places around the globe, because we have the data, is defining a dark sky place. So here's 5 different types of dark sky designations, dark sky place designations. Dark sky community, a dark sky park, a dark sky reserve, a dark sky sanctuary, and an urban night sky place. So there's plenty of opportunity for you to work in a city park, in a municipal location, way out in the country, thousands of acres. There's many opportunities for us to begin designating these places where we only allow sensible lighting in that location. And I say allow, and that's kind of a soft thing. These are not legally binding. Nobody here wants to make some sort of rule or law that says you can only put up this kind of light fixture. The idea is that we all buy into the natural beauty of the night sky, and we don't want to ruin it together as a multicultural resource. Okay, so we are in that process of looking at an international dark sky sanctuary here in southeastern Oregon. But in this pursuit, we need to have more data. Where is it dark? Where are we in that threshold of dark or gray to blue? Okay, so we can really capture the sanctuary boundaries in the really dark locations. So this is how this began. General map of the United States. Here's a giant area over here that includes Oregon that's very dark. So the Oregon Outback Dark Sky Network emerged out of this idea, led by Travel Southern Oregon for the most part. And Friends of the Owyhee has officially joined the steering committee. And we've done some lighting inventory in the area. We've done some sky quality measurements to try to begin understanding the Boise light bubble as it invades the Owyhee. So a couple of months ago, the Oregon Outback Dark Sky Network presented at the 2022 Oregon Governor's Conference on Tourism. And here's the crew that we have here. And I just adore this picture, mostly because of Bob Hackett here, who's wearing the blue mask from Travel Southern Oregon. And that mask, you might recognize the mustache, is kind of like the Lorax. So he presented this idea at the conference that kind of like the Lorax speaks for the trees, is we need something just as charismatic as an idea that's speaking for the night sky, right? And if you don't do it, what is the saying? Unless you stand up for the trees or the night sky, then potentially nobody else will. So again, become a dark sky advocate as much as you possibly can. In the right-hand side here, here's a map that shows a portion of the Pacific Northwest and all of Oregon. And in the red boundary here is our preliminary boundary for the Oregon Outback Dark Sky Sanctuary nomination, as we bring forward our collected data on how dark all of these areas are to the International Dark Sky Association. TBD on as we move through this process, whether it's this is what the boundary exactly looks like, or we might have to move some things. Okay, but we're well on the road. Okay, I see a big smile by MJ there, right? It's pretty cool stuff, huh? So another portion of this is citizen science. So I've been out collecting data, but you can also involve yourself in this data collection. So again, email me or contact at Friends of the Owyhee to get to Catalan, and we can figure out a way that we can plug you right in to do a lighting inventory, to do an SQM measurement, sky quality measurement, so we can continue this ball rolling. So one of these projects is the Oregon Sky Glow project from the International Dark Sky Association Oregon chapter. And on April 16th, so just a month ago, they produced this report. It's actually linked in here. So when you get these slides, you can use this link. But this shows a whole set of continuous sky quality measurement data stations. So this is a sky quality meter that's sitting out in the middle of nowhere that's taking data of the night sky every minute or so. And I wanted to bring this up to show you exactly how little data we actually have about Malheur County. So over on the right-hand side, you can see all the stars out here in Oregon. There's the Wallowas. You can look down to, there's Hart Mountain in the Alvord Desert. But look at this, the whole Owyhee network, all of Malheur County, we got nothing, right? So it is very important, I think, at this stage of including Malheur County in the Oregon Outback Sanctuary as soon as possible, that we get a continuous sky data logger out there somewhere. So Friends of the Owyhee, we're just beginning to pursue this, but it's all about funding, right? So we're trying to collaborate with the Eastern Oregon Visitor Association and the IDA Oregon chapter to get one of these eventually, but maybe this is a good opportunity to ask for a donation around this. So if you have or have not donated to Friends of the Owyhee in the past, you probably know some about our projects and some of the things we do. But this is one of the things we do, and it's your donations that really help drive these projects to make sure that we have the resources to do them. So in this project, this is not just the time and the resource for me, but this is like a $400 instrument. So not only do we need to coordinate with a landowner and put the instrument out there, we want to get the funding for the instrument. So yeah, thanks in advance for any help that you could muster. And then the other project that you can be a part of is actually collecting using an SQM, this little handheld object. dark sky data. So this is available at both the Harney County Library in Burns and here in the Ontario Community Library. You can check out one of these kits, and it's super interactive, right? This is so wonderful. The stars, it's static. Stargazing is super fun. You know, you can use the hands, but it's really nice for children. So say, you know, 12 and under, to have something to do. You know how they like to have something to do. So just getting a device in their hand for them to be able to collect some data and for it to give some numbers, and you can record those, is a really enriching activity for 15, 20 minutes of stargazing. So highly recommend checking out a kit from the Ontario Community Library. And then you can also use your space phone to submit data. Okay, sorry, I say space phone all the time just because it's like space age technology in my pocket, but the smartphone. You can visit globeatnight.org for this month's upcoming citizen science campaign. It's May 21st to the 30th. And there's also a couple of apps that you can use, but those don't plug into the citizen science data that we're using for the Oregon Outback Dark Sky Network, but they're apps and they're fun, so you can use those too. But the globeatnight.org project asks you to use your phone and go outside and compare a constellation and the bright stars of that constellation on a few pictures on your phone. So the bright ones all the way to the dim stars. So to compare that, and that's kind of a proxy for the darkness of the night sky. You see what I mean? So it's not an actual measurement in candelas of the darkness of the night sky, but based on the number of stars that you can see in the Bootes constellation is a proxy for the darkness in that area. Okay, so it's really easy to do. I highly recommend you check it out tonight. You can submit your data, even though it's not within that window tonight. Okay, it's not an app. It's just globeatnight.org. So if you're going to use it tonight, I guess you need to know how to find Bootes then, right? So tonight at about, what did I say, 10 p.m., if you look to the south, you will find way over on the western horizon, you'll see the bright star Procyon. Okay, and that's where I'm going to start. Okay, just to start getting the bright stars out of the way. You'll see the bright star Procyon. It's kind of bluish. Maybe you know, all the stars are kind of light. But this casts a slight blue hue. So moving from Procyon along the ecliptic towards the south, so about 50 degrees up from the horizon, you'll see Leo that has that characteristic sickle shape, or sometimes I call it a backwards question mark. Okay, so there's the head of the lion, and then there's the triangle, the right triangle back there that makes the tail of the lion. So there's Leo, the constellation. And if you keep going down towards the horizon, you'll see another very bright star, almost exactly in the south, depending on what time you go out. If you go out about 10:30, 10:45, it'll be right on south. But that's the star Spica that's within the Virgo constellation. So there's Virgo, kind of just what that looks like in space. And then above Virgo, so by above, I mean away from the horizon towards the zenith, and the zenith is the point directly overhead. You'll see a bright star that's much more white in color, even has maybe a longer wavelength of even a yellowish kind of color. That's the star Arcturus, very bright, one of the brightest stars in the night sky right now tonight. So you can't miss it in the south. And that's part of the Bootes constellation. So here's Bootes. He's the herdsman in the Greco-Roman mythology. Okay. All right. As I've mentioned probably a couple of times by now, these are all archived at the Friends of the Owyhee YouTube page. So here's what we did last year, the whole cycle, and then here's what we're up to this year. The 5 circumpolar constellations from March, that's up there. Tonight's about the visible planets. And then on the next time we do this is July 13th. So it's a little bit earlier in the month than we've been doing this. And and we'll look at the 13 zodiacal constellations. So those are the constellations that the sun actually transits through. Okay, you might think of them as the 12 zodiac constellations, but there's actually 13 we see astronomically. All right. Now for the meat of the material. So now is where the notepad comes out. If you got some of that handy, maybe your space phone comes out because you're looking at Stellarium already. All right. But what we, to set our awareness in this process, most of the time we're looking to the south or to the north when stargazing. I mean, yeah, we look around a little bit, but a lot of action is happening in the south during the year as the constellations move through the night sky. This is where all the new stuff is happening. And then we look to the north to look at the circumboreal constellations, or circumpolar. That's things like the Big Dipper and Polaris, the North Star. But looking at the east and the west during sunrise and sunset is really common. So that's kind of what we're going to do for this lesson, because the planets that we want to see, just like our planet, they're all orbiting the sun, right? So the planets tend to be, from our point of view, relatively close to the sun. Okay, so that's why the rising and the setting sun is important when we're looking for planets. All right, so we're going to look to the east during sunrise. The season, you can look this year during April. Well, that was in the past. May right now, and all the way into June. And that's for the Northern Hemisphere. So sorry, Southern Hemisphere folks. Then the sun rises here in Ontario at 6:15 a.m. So that's when not just it starts to get really bright on the horizon, but when the orb is coming up over the horizon. So that's far too late to be doing this morning stargazing. Okay, so you want to do all of this stuff. I recommend between 4:45 and 5:45. So hopefully you're an early riser, at least just once. Okay, and then for right now, the moon is 92% waning away. It'll actually be on the opposite side of the night sky right now. So it'll be over in the west, about 30 degrees from the horizon. And then, so what's the process here? Well, first of all, you got to wake up. That may or may not be difficult for you. So set an alarm. It's only going to take a couple of minutes to go out and stargazing, and it'll be incredibly rewarding. And then you can go back to sleep even before your shift starts, right? So wake up, grab some coffee or whatever it is, some tea, drink something in the morning, do a little exercise, get your blood going, something to get your wits about you so you know that you're looking to the east. And then go on outside. So ideally, you could do this from your home or maybe a local park. But possibly if you don't have a good, clear view of the eastern horizon, you might want to choose a location that you're going to drive to that you can get up a little bit higher so you can get above the trees, maybe above buildings, maybe there's a local hill. Like I usually think of the Ontario Heights area or the Foothills Drive area. I like to drive up there with students so we can see the whole valley out to the east. But just keep that in mind. Now, it's not as essential right now. You're going to be able to see Venus and Jupiter, no problem. But later in June, if you want to see Mercury, it's really important that you get a very clear view of the eastern horizon at that time. So preceding sunrise, as the rest of the stars fade away, the planets, the really bright objects, are going to stay there. So just before sunrise is a really good time to be looking for these planets and being confident that you're seeing the planets. Okay, and then through the next few months, the planets will slowly change position. I'll show you a couple of images with that. Okay, we should maybe start off on academically, what is a planet? Before I show you these things, maybe you already have an idea in your mind of what we might see. But a planet, the Greek astronomers called these things asteres planetae. or wandering stars. So planet means wanderer. And the reason they called them wanderers is because the planets actually move at a different rate than the rest of the stars. So they will shift positions all year, every day, and they will never be in the same place. So if you're learning constellations, you can learn Big Dipper and Polaris and Cassiopeia, and they are going to stay there in the same place relative to each other for your entire life. Okay, but not the planets. And that's so cool. They actually move around the night sky. Now, wanderer is a little misleading because it's not like they go around randomly. Okay, the planets, remember, they are all orbiting the sun. And not only are they orbiting the sun, but they also orbit the sun along a certain plane. And all of the planets are along that plane, plus or minus about 13 degrees, I think. I think Neptune is off by about 20 degrees. But either way, all of these planets, not only do they orbit the sun, but they're all orbiting in the exact same plane. Okay? So as we see them from Earth, they're on the same plane as the sun. So the arc that the sun takes across the sky, you can imagine that in your mind right now. That's the same arc that you would expect to see the planets on, and the moon. All of the celestial objects that we can see in the solar system fall along that same arc of the sun. And we call that the ecliptic. The ecliptic. Okay, so that's a little bit about the planets as wanderers. Today, we understand that the planets are celestial objects, just like we reside on a planet, that are all orbiting the sun. In 1930, the 9th planet, Pluto, was discovered, just as a lead up to this next part, that since then, thousands of planet-like objects have been discovered and named. Thousands of objects are out there. The trans-Newtonian objects, they call them. So that's everything past Neptune. And in 2006, because there were so darn many of them, the International Astronomical Union just decided, they came up with rules, just like humans like to do, and they voted on said rules that a planet has this definition, that it orbits the sun, that it must be round or round-ish, and the last one, and Pluto doesn't fit this, is that it must clear its neighborhood of like-size objects. So Pluto has a moon, Charon, that's about 2/3 the size of the planet. So over time, many satellites will, as they get closer to the planet, they'll disintegrate and are no longer a satellite or a moon. Our moon, on the other hand, is drifting away from us. So neither the Earth or Pluto has actually cleared the neighborhood of like-size objects. So it's just kind of weird, because if you placed Earth out at Pluto's distance, we wouldn't fit the criteria to be a planet either. So I, as a geologist, reject this idea of the planetary definition that the astronomers came up with. And as geoscientists, we maintain our own definition of a planet. It's a little bit more convoluted, but basically this says, and it includes Pluto, a substellar mass, so anything smaller than the sun, that has never undergone nuclear fusion. So Jupiter, right? It's big, but it's never undergone any sort of fusion process. And then it also has enough self-gravity that it assumes a spheroidal shape. So that's the round thing. And we'll leave it at that. Okay, that includes Pluto and a bunch of other dwarf planets, and allows then geologists and planetary scientists to study a whole lot of other objects. Okay, anyway, that's my little plug for Pluto then, right? All right, the visible planets. When we say visible, we mean with the unaided eye. We're not going to use a telescope. You don't need to. You could use binoculars if you wanted to, but you're not going to see anything in any greater resolution. You might get a little better idea of, say, Mars, because it's pretty small, and the color of Mars, which is kind of reddish, and Saturn. But other than that, it is a joy and a pleasure to use the unaided eye to see the visible planets. Okay, and then just last weekend, I was camping with a group of students doing a youth leadership camp, and we looked at the planets. We got up at 5:45 in the morning to go look at the planets. And one of the kids said, "Those look like stars." And I was like, yeah, I guess they are, right? They look like that. So the rule of thumb here, we've talked about this before, is that stars have a kind of a twinkle to them and planets don't. And the reason being, the stars are so remote, they're light years away from us out there in space, that as the light travels across space and that long distance, there's some undulation in the speed of light as it goes through asymmetries in the density of space. So the light is actually coming to you in squished or elongated waves. So the stars have a slight tinkle to them, where the planets, they're like our close neighbors. They're really, really close. So the light that's reflecting off of the sun, or that's coming from the sun and reflecting off of that planet to us, is pretty pure wavelength of light. Then, so I just want to be clear, what we're not going to see then, speaking to that, that student's comment, is we're not going to see this. We're not going to see big, bright, giant Jupiter with the giant red spot and the Milky Way back there. This is a photoshopped picture, right? And then we're also not going to see all the gigantic planets out there and be able to count the rings of Saturn. Just want to be really clear with, when we're talking about the visible planets, it doesn't mean that you're going to get a telescopic view of the planets. Instead, you're going to be able to see these star-like objects in the night sky. All right, and then we have this common saying, when the planets align. And then this was an article that came across today while I was Googling some things. When do the planets align? What does this astrological alignment mean? Well, I don't want to burst any bubbles here, I'm not talking about astrology, but you know, if we see the planets from the Earth, they're always aligned along the ecliptic, as I said earlier, right? They all are on the same band as the sun. So every time you can see visible planets, more than 1, 2, or even 3, they are always going to fall in a line. There's nothing mystical or magical about it. Well, I mean, it's beautiful and magical, right? But it's not some wild phenomena that the planets are aligned. They are always in that shape, okay? All right, so tomorrow morning, I just imagine you are excited to go to bed right now so you can wake up at 5:45. Well, in this case, I set this for 5:30. Tomorrow morning, if you look out to the east, right on east, you will see the big, bright planet Venus. And it is big and bright. Actually, Venus gets reported several times a year as being a UFO, or an unidentified object in the night sky, because it's so peculiar. It's just really bright, and that catches people off guard. So it's not an alien, it's not an unidentified object, it's just a planet, Venus. Okay, and then if you follow Venus, if you go from Venus about a full fist at this point, tomorrow morning it's probably a full fist, to the south, you'll see a slightly smaller star-looking object. It's the planet Jupiter. And then only about a finger or maybe 2 fingers away from Jupiter, you'll see Mars. It's a small, faint star, but it's very clearly reddish orange, okay, especially when it's next to Jupiter. And then if you go about 18 degrees, again, this is at arm's length away, about 18 degrees and another half of a fist. I measured this yesterday morning, so it shouldn't be moved too much. You'll see another faint star-looking object that's Saturn. And let me warn you that Saturn is classically difficult to find. It really does look like a star. It's about the same size as many of these other stars, and it's dimmer than many of the bright stars you'll see in the night sky. So that one's a little bit difficult. So this is what you're going to see tomorrow morning. Okay, now let's go back in time so we can see this phenomena leading up to now, because that's the exciting part here. You can watch this just like the constellations every year in and year out. So about a month ago, April 19th, at 6:15 a.m., this is what we could see on the horizon. And this is what they were talking about in the news, as all the stars or all the planets were aligned, right? Nice line. You could see Jupiter, which notice is on the opposite side as Venus, as it is now. Venus, Mars, and Saturn, they were all a little bit closer to one another. So Jupiter and Venus traded places, right? If we go back to today, Venus is on the opposite side of Jupiter than it was back a month ago. So what happened? They're wanderers, of course. They move around the night sky. So between that point, on May Day, if you woke up on May Day to go set up your maypole at 6 a.m., this is what you saw in the eastern sky. Is Venus, because this is a inferior planet. It's closer to the sun than us. It moved in front of Jupiter from our point of view. So that's what we call a transit. Venus transit Jupiter. Venus, also because its orbit is much smaller, it's closer to the sun, so it's going a little bit faster than Jupiter that's way out there. Venus is moving a lot faster than Jupiter. So it actually moved for close, Venus was close to Mars, as you saw, and then it's moved on the other side of Jupiter and is now closer to the horizon. Okay, now let's go a little bit further in time then. We can see another transit happening on May 29th here at the end of the month. Similarly, you wake up early. So here at 5:15, you'll see Venus over there on the east, and then look for Jupiter, and you probably won't be able to see Mars. Okay, it's a tiny, tiny object, and it's red, and the closer that it gets to Jupiter, the more that Jupiter light's going to bleed out. Here's where you can use a pair of binoculars. Is you can look for, especially when it's dark out before the sun has risen, is you can look for the little black object of Mars covering up a portion of Jupiter. Okay, pretty exciting. And then by this time, Saturn is going to be way out there in left field. Okay, and then on June 20th is what I feel like is the real show here, the big moment. Even though the planets have been close to each other, in June and even earlier than this, depending on your view, we can see Mercury. So go to the east, you can find Venus, and then you can start to see in the morning where the sun's gonna about come up. And if you look from Venus back towards the horizon, look for a small star-like object there just below the Pleiades constellation, and that's probably Mercury. Okay, it's really close to the sun. At this time, Mercury will be at what's called its western elongation. So it's as far to the west as it will be ever. And then it'll start making its way back towards the sun before it comes back around in retrograde. Okay, so this is really exciting. I can't wait to see Mercury in the night sky again. Okay, so here's a little video. Excuse the watermark, but you know, a freeware. I'll play it twice. So this is going through all of those dates. It's going to start on April 19th, and then we continue, say April 19th. So you can see Venus and Jupiter coming up. You see they're all still in a line. There's the moon coming by during its full phase, and there's Mercury, western, and you see it turn back around. That's when it goes into what we call retrograde or backwards movement. Okay, well, I hope that you are as excited about waking up tomorrow morning to see this as I am. Of course, given that the sky is clear, you'll be able to see this, but sometime in the next month, it will be clear and you'll be able to get up in the morning, have your coffee, have your brew, and go out and really enjoy this beautiful celestial process. The night sky, the stars, the Milky Way, all of these things are exceptionally beautiful when you get to a natural night sky. But to me, I really do feel connected. I mean, not like literally, but connected to the planets, and being able to see them move around the night sky is really cool. So that's a little bit about gear, awareness, and process, the importance of natural night skies. And I forgot to change the last point here to talk about the visible planets. Let's do this again, July 13th, to talk about the 13 zodiacal constellations.